All right. I'll talk about evaluation and monitoring of LLM applications. I co-lead Snowflake AI research and recently joined Snowflake through an acquisition of my company, Truera, which I started about 5 years ago out of CMU, where I used to be a professor. So lots of gray hair, or whatever little hair is left. This area I have seen really explode over the last decade, and it's been great to be part of this community in this journey. With me today also is Prithvi Dharmana over there. Prithvi is our engineering lead for this area. So if you have hard questions, he will have the answers. This is not a slide I made, but the era of enterprise AI is here, but not always in production. It's been incredibly hard to get generative AI applications that are built over the course of a day or two or a week to really deliver value in production in enterprise settings. And these are the kinds of representative apps that we are seeing in enterprises. Summarization, chatbots, retrieval augmented generation based applications for question answering, which Roy talked about earlier. Coding copilots are increasingly becoming popular as well for, say, natural language to SQL generation, or even regular software, Python, Java, and so on. This is starting to mature. But we are also seeing LLM agent-based workflows emerge and starting to get some amount of adoption, as well as multimodal applications on the back of multimodal large models that are increasingly maturing as well. But what's stopping these applications from moving into production? We have heard of some of the challenges in operationalizing these applications, including infrastructure for inference, making it easy to build pipelines and so forth. I'll focus on a few others that have to do with quality and governance. And by that, I mean, even when you build a RAG application, you get hallucinations, you get irrelevant answers, you get incomplete answers, you get poor summaries. And then there's a whole set of governance-related concerns as well around privacy, the data on which questions are being answered, for example, content moderation, security. And then very real considerations of cost and latency come into play as well. Without addressing these challenges, it's incredibly hard to move these kinds of applications into production in enterprise settings. So I'll focus my talk on AI observability today, which helps address some of these hurdles. Specifically, let's return to the RAG-based applications that Roy introduced and look at some of the ways in which it might fail, or where getting to production grade is hard unless you do these steps really well. So when you start off with your data, you're chunking it up into smaller pieces, and there's a whole range of chunking strategies. Being able to explore that space of options, experiment with them to find the one that works best for your data is very important. Data quality is important. Understanding the query, the semantics of the query tends to be important. In this search box, inside of this box is the kind of retrieval with vector databases, or augmented with semantic search and re-rankers and so on. That has impact on retrieval quality, on embedding quality. Cortex Search is one instance of this that Snowflake has built. Pinecone has its own retriever. There's a space of options here to explore. And then finally, when you get the final response, you can get hallucinations despite your best efforts in all of these other areas, because LLMs continue to make stuff up. So as we think about this whole experience of building apps and taking them to production, these are some of the requirements that we have heard from our enterprise customers previously at Trera and now at Snowflake. The first is around evaluation and experiment tracking to choose the components that offer best-in-class quality, cost, and latency. So think of this as a bit of that Pareto optimal frontier. Quality in isolation is not enough unless it's balanced with acceptable cost and latency. This means that we want to have tools that can help you track and measure the quality of your applications, the cost and latency that they're incurring, and make the best trade-offs. When you're building applications, developers want to be able to iterate rapidly through an evaluation-based workflow to understand failure modes, to improve apps, and then finally, when these apps move into production, to monitor and guardrail to maintain these apps in production. And that's what we built out, initially through an open source project called TrueLens, which then also became the engine of an enterprise offering. And now we are in the process of integrating and building that out as part of the Snowflake AI platform. TrueLens was one of the first projects in this space. It was launched in May of 2023, around the same time as this other project that Roy mentioned because of an error, I'm assuming, in his speaker notes. He meant to refer to TrueLens, would be my guess. As developers build their application, they instrument the application with TrueLens. They import it to the library, instrument it, and then the entire execution trace gets logged, and then evaluations are computed over those spans of those logs, and you can get a visual presentation of how your application is doing with respect to various metrics. And when it's not doing so well, you can drill down, understand what's causing the issues, and get guidance on iteration and improvement of these applications. So let me show you a little bit of what it looks like to instrument an app. So this is a code snippet from a RAG application. It has that retrieval step when you go out and call out to Pinecone or Cortex Search. Over here is the completion step, which is from the retriever, you got back, say, 5 pieces of information, and then those get summarized. The details are not so important, but you'll notice here the @instrument decorator. That is essentially telling the application that as you execute that application with this instrumentation, it's going to log your entire execution trace in some database. And then later on, you can compute evaluations over spans or parts of these traces. And the nice thing about TrueLens is that you can take your Python application and instrument it with TrueLens, and then you'll get the logs automatically through this process, and evals can run over them. Or if you already have logs created through some other mechanism, let's say it's not a Python application, it's a Node.js application, but you are putting your logs in OpenTelemetry format or something, we can also read the logs directly and do the evaluations. Both of those modes work, depending on what you prefer. So this quick start is from, the code snippet is from this Colab notebook. If you're interested, we'll share the slides after the session. You can go play with it. I can actually show you a bit of what TrueLens looks like. This is the GitHub. There's the quick example of a quick start. This is what I was showing you. There are nice integrations with Llama Index and LangChain. And we had done some work with Canopy as well. So for Pinecone users who have played with Canopy, you don't have to do as much work to instrument, where you instrument every function that you, in this example, you're instrumenting every function that you want to log. For more native integrations with Llama Index or LangChain or Canopy, you can just write one line of code, and in the back end, things work seamlessly. Cool. So now that we have logged the execution, I'll give you a sense of the kinds of metrics that you can track as part of the evaluation. Last year, we introduced this concept of the RAG triad. This has now gotten widespread adoption. Lots of other open source libraries are using it, as are commercial offerings. And the idea of the RAG triad is that it very much follows the structure of a RAG. And for each step here, say the user comes in with a query, there's a set of retrieved pieces of context from your favorite vector database or search. And then in this step, what you will be evaluating is this metric that we call context relevance, which checks, is the retrieved context relevant to the query that you're asking? And it'll come back with a score indicating how well or how relevant it is to that context, to the query. In the second step, the groundedness evaluation is checking for the final response, how well grounded is it in the retrieved pieces of context. So this is the step where hallucinations usually creep in, because even if you give an LLM 3 pieces of information and ask it to summarize it, it can still make stuff up, which is what Roy was talking about in the beginning. And groundedness helps catch these kinds of hallucination. And then finally, answer relevance checks. Is the answer relevant to the query? Let me show you an example of TrueLens built into this question answering RAG-based system, where I'm asking when was the University of Washington founded, and then I submit, and it comes back with an answer that it was founded in 1861 in Seattle. And then if I go down here, you see the RAG triad metrics. Groundedness is pretty good. Answer relevance is also good. On a scale of 0 to 1, they're both perfect. But context relevance is not. It's only a quarter. And you can see there are these 4 pieces of retrieved context. The first one is highlighted in green because our automated evaluation judges that this is indeed relevant to the query that was asked. And you can see here it's referring to the University of Washington being founded in 1861. The second one here is marked as red because it's not relevant to the query that was asked. And if you look at the details here, instead of referring to University of Washington, it's referring to Washington State University. And this is where embedding-based semantic retrieval can go wrong, because University of Washington and Washington University are semantically pretty close. And so your retriever may not be able to tell the difference between those, but having an additional layer of evaluation, which under the hood here is making use of an LLM as a judge, catches this. And you can have filters based on that, and the final answer picks the highly relevant context and ignores the ones that are not very relevant. In the interest of time, on groundedness, I'll just give you a very quick view of an example. If the demo goes are on my side, which maybe not. But maybe I'll just speak to it here. What groundedness does is for every sentence in the final summary, final response, it's going to either say that it's it can be traced back to one of the pieces of retrieved context, and it'll show you which piece of context. Or it'll say that it's not backed up, that it's actually hallucinatory. There is no supporting evidence. And under the hood, this is making use of automated evals based on LLMs as judges. Now, that's not the only type of evaluation that's available in TrueLens. TrueLens supports a wide range of evals with and without ground truth. For ground truth evals, you know what the correct answer is already in the ground truth data set, and it's just checking if semantically the answer that comes out of the RAG matches the answer in your ground truth data set. That's a great place to start when you're doing evals, but let's say you have built an app and you've moved it into production, then you don't have ground truth when you're running it live. So it's important to also have automated evals, which is what's available here above the bar. So the demo that I showed you is making use of LLM evals as judges, but the other area where we are doing quite a bit of work is working with smaller models that can do judging at a similar level of trustworthiness, but it ends up being a lot more cost effective. So when you start using LLM as a judge in RAG-based applications, you are adding a bunch of latency and cost to your operations, and doubling the cost of your operation, for example, may not be acceptable. You can address that to some extent through sampling in the production monitoring setting, but it's also really valuable to start using smaller models. So that's a big area of work that we are focusing on right now. I gave you some examples of evals. There's a lot more out-of-the-box evals that are available in TrueLens that help with ensuring that apps are honest, harmless, and helpful. The RAG triad falls here in the honest bucket, but you also want to be guarding against stereotyping and toxicity and adversarial attacks through jailbreaks and so on. And we have capabilities in these areas as well. One interesting experience working with a bank at one point was they were playing around with TrueLens in there for a customer-facing chatbot that they were experimenting with. And some user came and asked the chatbot, I'm considering getting a mortgage, and I'm also considering getting a divorce. Will that have an impact on my mortgage rate? And the chatbot very helpfully advised them that it is not a good idea to get a divorce because your mortgage rate may not be to your liking. At that time, when they were doing the evaluation with TrueLens, this falls in kind of this category. I've not exhaustively listed all the evals, but one of the evals we had was around controversialness assessments. And then that score went up really high and triggered an alert. So when the app developer looked at that example and then talked to people higher up in the organization, they decided that they needed to put this into production, having these kinds of guardrails, not just offline monitoring, because knowing 2 days later that this happened with a customer was not good enough. So that guardrail mode of online evals is very important in many settings where concerns of harm abound. It's also important for accuracy. A couple of things in the remaining time that I'll highlight is in August, once we were at Snowflake, we put out this version 1.0 of TrueLens, built it out to be much more modular so that the core is much smaller. We are focusing only on the very core tools for instrumentation, database operations, guardrails, and feedback. And then other things are getting pushed out into other packages. This makes it interesting for, or it's a much more security conscious design, and that keeping on top of security vulnerabilities is easier in the core. All other things are optional and can be used incrementally. From an enterprise perspective, there are a couple of other resources that I wanted to point you to, which are motivated by both considerations of scale and considerations of governance. So one thing that we have heard always at Snowflake from enterprise customers is that often they put the production data in Snowflake because they like the data governance, the lineage tracking, all the good stuff that many regulatory requirements and just good governance demands. And so one thing that we did in this quick start was that even if you use TrueLens on the client side, the execution, the production logs, the execution traces get logged into Snowflake, and evaluations can be run either client side or server side within the Snowflake perimeter. So there's a nice quick start here linked from this page. We'll share the link, but this has a bit of a walkthrough of why even you can use this with open source and with a trial Snowflake account, or if you have a Snowflake account already, please try it out. One other area where we have been doing quite a bit of work is benchmarking. When you're using LLMs as judges, a big question is, now you're using an LLM as a judge to judge an LLM app. Is it just turtles all the way down, right? So one thing that we have been spending quite some thought on is grounding, or I shouldn't use the word grounding, that means something else here, but benchmarking these LLM as judges against data sets where the ground truth is known. So you know what to expect, and then you can see if what the judge is saying lines up nicely with what you expect. So we did these. This is a summary of some experiments with the SumEval data set, where there is a big document, there's a summary of that document. A human is being asked, is the summary consistent with the original document? So the human has given some scores, and then our groundedness LLM as a judge is also doing a similar evaluation, and then we are comparing how well aligned those are. And that accuracy evaluation is measured in this mean absolute error. So smaller numbers here are better. And you can see that GPT-4o and Llama 370B instruct here do quite well around the 5% mark. Snowflake has this Arctic instruct model that's about 2% behind it. But on the latency side, Arctic is doing like twice as well as Llama 370B. So these kinds of evaluations are, again, very helpful to pick the right LLM as a judge. Here are a few other lines of work that are ongoing at the moment. One is integration with open telemetry conventions. So we talked about instrumentation and logging, but it's very common to work with customers who already have their own logs. And many of them are using open telemetry conventions and SDKs and APIs. So we're building out these integrations so that if you already have logs, then you can easily work with TrueLens. I talked a bit about benchmarking and improving LLMs as judges with one example, but that's something we're doing quite broadly. A third area is on building these efficient, smaller models for evals that offer better trade-offs in terms of cost and latency. And then finally, evals for LLM agents. So I talked quite a bit about RAG-based applications in this talk, but agents is another area where there's quite a bit of work both in building out specific agents at Snowflake, like Cortex Analyst, which does text to SQL. And then evals for things like that is something we're looking at quite deeply. And I know the next talk will talk about agents. So I'll pause here and take any final questions. Thank you.